Avalanches kill more people on national forest lands than any other natural hazard. The mission of the Sawtooth Avalanche Center is to provide avalanche safety information for people recreating, working, or traveling in the Sawtooth National Forest. To find ways to support our mission, visit sawtoothavalanche.com.
Hello, everyone, and welcome to the online Digging Deeper series. My name is Amy David, and I'm the media coordinator for the Friends of the Sawtooth Avalanche Center. The Digging Deeper series is where you get to learn and participate in discussions with the Sawtooth Avalanche Center forecasters. These presentations are scheduled for every other Wednesday from now all the way through April. And mark your calendars for the next Digging Deeper on December 9th with Chris Lundy to learn about the website and technology updates. And speaking of which, a new general avalanche information update was just published today on the website, which can give you a sense of the type of hazards you'll be dealing with out there this weekend. So please join me from afar in thanking the team behind the scenes right now. We've got Scott Savage, the director of the Sawtooth Avalanche Center, and he is running the technical workings of this webinar. And also the Sawtooth Avalanche Center forecasters, Ethan Davis and Chris Lundy, who played a major role in setting this program up. And soon I will introduce to you our final forecaster, Ben VandenBos, who will be presenting tonight. So we'd also like to send a huge thank you to the Friends of the Sawtooth Avalanche Center, including the board of directors, the staff, and each of you among the community who donate. The Friends is a nonprofit organization that provides over 50% of our local Avalanche Center's funding annually. Our mission is to support the Avalanche Center and promote life-saving avalanche safety information, education, and outreach throughout Central Idaho. So join us in driving our mission forward, realizing this vision, and building the best Avalanche Center in the West.
It's my turn. Hey, my name's Paul. I'm the head brewer and CEO and owner of Sawtooth Brewery. Cheers. Happy Thanksgiving. Hopefully you can make it in after the webinar for our 50% off beer to go sale, our only big beer to go sale of the year. Stock up for Thanksgiving, stock up for December, because nobody's excited when you bring a clear lager to Thanksgiving. I'm excited to help host the webinar series this year. We all live in Sun Valley for a reason. We all recreate. We love this area. We play here. And Sawtooth Avalanche Center definitely enables us to do so in a safe manner. And without the work of the Avalanche forecasters and the Friends of the Sawtooth Avalanche Center, we definitely would just be lacking in information. So a big thank you to those folks for making everything happen for many, many months out of the year, for helping us head out there safely, for educating us, being the public outreach. And yeah, we're just excited to partner with them once again, as always. And I think there's a great crossover between enjoying the outdoors and enjoying some craft beer. And look for some craft seltzer and craft non-alcoholic beer from Sawtooth Brewery coming out in the next few weeks. So cheers. Let's raise a glass. Thanks for signing in, showing up. Happy Thanksgiving from wherever you are. Stay safe and slow that spread. Cheers.
Thanks so much, Paul. So this community has always been so supportive, and in past years, many businesses have hosted the Digging Deeper series events at their locations. And so tonight, we really want to thank Paul and everyone at the Sawtooth Brewery for that continued support into this year. And it looks like we may have had a few technical difficulties with showing the Friends video, but we will make sure that we get it out to everybody. And we will move on to the main event. So that is Shake It Till You Break It, Earthquakes and Avalanches, presented by Ben VandenBos. And Ben was perfectly positioned for this event and this presentation He studied geology in college and has worked with the Sawtooth Avalanche Center for 5 years. So the double whammy of earthquakes and avalanches are right up his alley. If you know Ben, you know he spends every waking second that he can walking through these mountains. So he was a great person to document what happened with the events surrounding the earthquake last March 31st. And I will let Ben tell that story. So take it away, Ben.
All right. Thanks a bunch, Amy. And thanks, Paul, and the folks at the Sawtooth Brewery for having us. And thanks to all of you for being here, and excuse any technical glitches that we have. Our specialty is looking at the snow. Zoom is not our specialty, but we're going to do the very best we can. So we'll just launch into it. See how this works. Can you see that screen there, Amy?
Yes, we can see it.
All right. I'll give you guys just a real quick look at Zoom and how to ask questions during this presentation, in case you're not familiar with it. On the bottom line of the screen there, you can see there's kind of that raise hand button. If you guys have any questions and you want to address those questions via your audio, raise your hand and we will unmute you and you can ask a question. And then there is also the Q&A box there on the right side of the screen, or the right side of the center of the screen there. If you want to type a question into there, Amy will feed those questions to me and I'll answer them as they come up. We usually, obviously we've done these live in the past in front of you guys in person. That's not the case tonight, but I'd still encourage you to interact as much as you can. If you have a question, if something doesn't make sense or sticks out to you, put it in the, raise your hand and we'll unmute you, or put in the question and answer section and we'll see what we can do to answer your question. Let's make this interactive, and I want you to be a part of this as much as we are. Oh, there's a look at the kind of that question and answer box. All right, I'm going to start with just a real quick look at the snowpack that we've got on the ground now, a little discussion of current conditions, and then we'll dive into the presentation. This is a map from basically right now. You can find this on our website if you want, and it's showing snow depth at different locations. We've got anywhere from about 1 to 3 feet of snow on the ground in the 1-ish to 2-ish range down south, and then up in the Sawtooth into the Banner Summit area, we've got 2, 3, pushing 4 feet of snow in some locations. Most of that snow fell in the last couple of weeks, particularly down south. We basically buried dry ground starting on the 13th. We had two big storms that produced quite a snowpack for us. And in these areas where there's only the new snow, we've got really pretty decent stability right now. I've got a right side up snowpack. It's denser at the ground and becomes less dense as you go up. No real widespread weak layers. There's kind of an interface between two storms that bears paying attention to, particularly as time passes without precipitation. And then the surface of the current snow surface is something to keep in mind and keep your eye on right now as well. Conditions are kind of these cold nights we've been having. Our cold, moderately humid nights are producing a decent bit of surface hoar, and it's faceting that upper bit of the snow surface. So right now in those areas, that weak snow at the top isn't a huge issue, but when we bury it, it is going to be an issue. We've been seeing some avalanche activity, unsurprisingly, given the intense storms we've been having. Both these photos show wind slabs in the Sawtooth that I spied last week. On the left there, it's below Williams, and then Goat Creek drainage on the right side there. Wind slabs involving just new snow from the storm that started about a week ago or so, and then tapered off into our nice clear weather. But in addition to that, we do have areas where we've buried some weaker, older snow. Both of these photos show avalanches in the Sawtooth that appear to have broken on some older weak layers. We can't get away with a stable snowpack in this area. Of course, we've got to have some buried weak layers, and don't worry, they're out there already. That older snow is relatively isolated. It's a pretty specific distribution. You're going to find it on upper elevation slopes, on slopes that are shaded where the sun wasn't able to melt it away. But where you're finding that old snow, it's definitely problematic. It's worrisome. And as we continue to load that, and even now, it's something we need to be worried about. We're issuing twice a week general avalanche updates right now. Like Amy said, Ethan just kicked one out this evening. Those give you a good sense what's going on with the snowpack, and they're also accompanied by weather forecasts, which are great if you want to go find nice days to enjoy the outside. And when we have a bit more significant storm on the horizon, we will transition to doing daily forecasts for you. So I think that deals with most of the housekeeping. Let's jump right into this. Earthquakes and avalanches. I guess I already mentioned, big thanks to Paul and the folks at the Sawtooth Brewery. They've provided us with many beers over the last number of years. It provided you with beers at these events, and we really appreciate the support that they've given us. So go down there and drink a few beers or some non-alcoholic beverages, and whatever suits your fancy. I'm going to start with an acknowledgement slide because people always kind of get buried under the rug if you put this at the end of it. None of this stuff happens by yourself. None of it's an individual effort. Huge thanks to obviously all the guys at the Sawtooth Avalanche Center, Chris, Scott, and Ethan, and Zach Keskinen at MSU, Zach Lifton at the Idaho Geological Survey, and Lee Liberty at Boise State all deserve a special call out. They've been immensely helpful in understanding the geologic framework of this event, as well as kind of looking at different ways that we can look at avalanches. So I'm talking to you about earthquakes and avalanches, and we need to have a little bit of a framework for the earthquake section of that. I think we all have a bit of a sense for avalanches, but earthquakes may or may not be something that we're familiar with. This map is showing you the major tectonic plates of the surface of the Earth. We're in the North American plate, kind of in the upper center there, obviously. And these plates are kind of migrated around the surface of the Earth, and where they interact at plate boundaries are the areas where we see the most earthquakes and as well as the largest earthquakes. But they're not the only place we see earthquakes. We also see earthquakes in the center of plates and in the middle of these plates. Pieces of these plates are, they're deforming rigidly, and they're moving, essentially sliding past each other. But that motion doesn't happen. It's not a smooth motion. Along those fault surfaces, those plates will get hung up. There's a lot of friction there, and they'll just stay there hung up for a while. And even though either side is trying to move past, and you're accumulating this energy there, you're not seeing any motion on it. And as that strain energy accumulates, eventually you get to a point where the friction on that fault surface isn't enough to hold back the two plates, the two pieces of crust, and they slide past each other. And that event is what we know as an earthquake, and results in shaking of the ground. And that's exactly what happened in the spring of this year. This figure here, we've zoomed down to the central Idaho region there. If you look, you can find Stanley and Sun Valley, Chalice, kind of get yourself organized. You can also see the Snake River Plain at the bottom there. The white star in kind of the center left side of the image there, that's the epicenter of the Stanley earthquake. And you can see some of the mapped faults in the region. This earthquake occurred at the end of the Sawtooth fault, kind of actually off the mapped end of the fault, where that fault meets these trans-Chalice faults. It's actually a pretty complex geological setting, and it's not super well understood at this point, but there's a lot of really interesting work going on to understand this a bit better. That'll be interesting to see how some of that shakes out. This portion of central Idaho has hosted 4 out of the 5 of the largest earthquakes on record for Idaho, including the largest one, the Bora Peak earthquake, which occurred in 1983, almost 20 years ago. That was a magnitude 6.9. And the earthquake that occurred this spring was a magnitude 6.5. That was the largest earthquake since that Bora earthquake. Okay, I think that gives you a little sense of the geology, a little setting there. Kind of think about the rocks a little bit, but let's jump back to the snow world. going to spend a little time talking about the kind of the lead up to the earthquake, or the early season events that built the snowpack that the earthquake affected. So it's kind of fundamental to understanding what happened during the earthquake. Both these photos are taken in about mid-December. The one on the left is near Galena Summit, and the one on the right is in the Sawtooth. You can see Hanson Peak in the background. And most prominent in both of these photos is that thick layer of depth ore sitting right on the ground. That depth ore was buried right on Thanksgiving, or maybe the day before Thanksgiving of last year. And it was most widespread in areas north of Galena Summit. Here we are in that profile basin. You can see Thompson back behind there again. And this is a video of me doing a PST, propagation saw test, on that weak snow near the ground. We watched that weak snow for a while. We were concerned about it. We could tell that it wasn't going to hold up well to a big load, but there really weren't a lot of big loading events going on early in the year. However, that changed in the middle of January. Starting on about the 10th, we had a week-long series of storms that brought 3 inches of snow water, over 3 feet of snow to the northern portions of our advisory area, the same areas where this week's snow was best developed. And unsurprisingly, we saw some pretty significant avalanches as a result of that. We're looking at the north face of Williams Peak here. Thompson's in the background there for scale. And that red dotted line is showing a crown that's about almost 3/4 of a mile wide, a series of crowns in that basin. And crowns like this were just everywhere in this area, in the Sawtooth and in the White Clouds. Talking to some folks from around the area, this is the most widespread deep slab cycle they'd seen in the Sawtooth. Typically, these mountains host a pretty wet snowpack. They get a lot of snow, and you're not often able to preserve and hold on to this weak snow near the ground for a while. Usually, it gets flushed out a little bit earlier. And the reason we're talking about weak early season snow, not avalanches right now, is because or not earthquakes, excuse me, right now, is because the earthquake shook the snowpack that was on the ground, and that snowpack forms over the course of the entire season. Here we are. This is a graph of the Bench Lakes weather station, the height of snow, which is the snow depth at that weather station. It's the weather station we operate out near the range front of the Sawtooth. It's not terribly high, and it doesn't report as much snow as the upper elevation peaks get, but it gives you a sense for snowfall. And looking across this graph, you see that line it doesn't change a lot over on the left we're in January, on the right we're in April. It really hangs out right around 50 inches of snow, about 4 feet of snow on the ground for the better portion of this time, right up until the end there. And along the bottom, with the danger ratings that we had for the Sawtooth zone, you can see we spent a lot of time in that kind of that moderate middle ground. Quite a few low days in there as well. Occasional spikes to considerable with wind and new snow, but really at the end there is when things got pretty interesting, and you can see that spike to high danger. So the morning of the 31st was my forecast morning, and we'd all seen this storm that was forecast coming. It was evident 10 days out that there was a big plug of water heading our way, and as it got closer and it became more certain, we could all see that avalanche danger was going to increase significantly. And sitting in the hot seat that morning, looking at storm totals to that point and looking at weather models, I was pretty concerned that we were going to have some pretty hazardous conditions out there. And indeed we did. This is a little quote from the forecast discussion that day, and I'll read it for you. Really the interesting portion, I've been joking about this, but to my friends, I say that I predicted the avalanche in this second sentence here, or the earthquake, excuse me. Today is the first day in 2.5 months that we have high danger in our forecast area. The ongoing pandemic reminds us that the world can shift underneath our feet. The storm in progress should remind you of the same. It's been a weird winter to say the least, one marked by an overall lack of snowfall and long periods of relatively stable conditions. Today is different. So I think that gives you a pretty good framing to the mindset heading into that day. And obviously this is all before the earthquake. This is before we knew that the entire world was our entire world was gonna be rumbling a bit later in the day. So I put out that forecast that morning, and then I did what I normally do. I watched weather stations, watched to see how accurate my weather forecast had been. I watched the weather where I was, which was down in Haley that morning. And then after watching it for a bit, I decided to head to where snowfall intensity was at its highest and where I thought avalanche hazard was going to be at the highest to see what was happening. So I hopped in the car and started driving north. I drove up to Banner Seminary that day and climbed out, hopped onto a few other folks had been on a skin track for a little bit that day before they wisely turned around, not wanting to break trail through the 3+ feet of snow that were on the ground. And of course, I lacked that wisdom. My legs didn't thank me for it later, but I continued along and came upon this at a certain point. I was able to peer into a starting zone. This 1 to 3 foot thick crown near the top of Copper Mountain. This is a couple hours before the earthquake happened, but as expected, we're seeing large natural avalanches even without the additional shaking of the earthquake. Continued to the top, and I made this moderately embarrassing movie I'm about to show you. We spend a lot of time trying to communicate what conditions are like in the backcountry to you guys. Sometimes the best way to do that is with movies. So we take a lot of these. A lot of them don't end up going anywhere because it don't seem like you say the right thing or whatever it is. And this was definitely one of them. But in retrospect, it's a pretty interesting movie. It's about 2 hours before that earthquake happened. And I think it sets the scene for what's going on in the mountains that day.
I can see my ski poles, a couple trees, and yeah, that's what I got for you. Here we go.
So I think that paints that picture pretty well. I skied down, avoided avalanche terrain, returned to my car, which looked like this on the highway. Pretty well plowed in. It was only about a lane and a half wide anyways, and just snow everywhere. And hop back in the car after an exhausting day of trail breaking and drive home. Excited about the avalanche I've found. Pretty apparent that there's some significant instability out there. Driving back, I come back into service and my phone just starts to ring off the hook. One text coming in after the other, and also got a call from my girlfriend that night as I was driving back into service, asking about if I'd felt the earthquake. And it was kind of shocking. I really didn't know what was going on at first. I'd been driving. Had not felt the earthquake and really wrapped my head around it because I had no idea it was coming. But slowly or quickly kind of started to think about what an earthquake would do during high avalanche danger. What happens when you shake the ground and you've already got an unstable snowpack on it. And I decided to find out what happens. We all at the Avalanche Center did work documenting the avalanches that we saw in the aftermath of that event. And this image here, I think, gives you a pretty good sense for what we saw. Up in the right there, you can see the epicenter. There's the town of Stanley. And then looking along the range front, it's about 40 miles from where the epicenter of the earthquake was, up by Banner Summit there, down to Alturas Lake. And all of those red lines in there are crowns that we mapped. We came up with almost 500 crowns, almost all of which are in this photo. There's a few avalanches out of the photo down to the south, but really this is where all of the action was. And when the avalanches that we saw, interestingly, were very widespread, obviously, but we weren't seeing a lot of bigger, deep avalanches. And rewinding back to that early season weak snow that we talked about, one reason that we didn't see, or one reason that I suspect we didn't see these avalanches, is because we'd already flushed out the slabs on top of that weak snow during that deep slab cycle in January. Had that deep slab cycle not happened, I would anticipate we would have seen far more large avalanches, far more deep avalanches. But it's a suspicion, not a true assertion necessarily. But certainly something, yeah, that we spent a significant amount of time thinking about it. The other way that we looked at these avalanches, and this may sound like science fiction, and sometimes it feels like it is to me, but was with satellites. I worked closely with Zach Keskinen at Montana State University, who's really interested in this remote sensing, as it's described, where you're essentially using data collected from satellites to try to make inferences about what's going on the ground, whether it's what type of vegetation there is, motion along earthquakes, along faults, or in this case, Zach's using that method to try to map the location of debris piles from avalanches. Essentially, what's happening is you have a satellite that's rotating around the Earth, and it's taking pictures as it goes, not pictures with visible light, but recording the electromagnetic wavelengths, whether it's visible or microwave or X-ray. These are all different EM waves that you can send down from the satellite. They bounce off the Earth, they come back to the satellite, and you record them. So you try to find an image before an avalanche cycle. You look at an image after an avalanche cycle, and you compare the two, and you can see differences in snow density and use that to infer the location of debris piles. And so the blue polygons that you're seeing on this image are the debris piles that Zach inferred from that satellite imagery. And if you look at the right, you can see a lot of those red crowns, the ones that we mapped. And in places, those line up with his polygons. And obviously on the left side of the image, you're not seeing any of those red crowns. The right side of the image, the eastern side of the Sawtooth, is the kind of the range front. Those two drainages that we see there are fishhook and redfish. And that's the sort of stuff that you can get to and actually see without walking more than 15 miles one way. Everything on the west side is pretty inaccessible during the winter unless you got a plane or a few days to walk back in there. It's interesting to look at the pattern of activity that you can see in these images. Obviously, there's avalanches across the images, but it's far more concentrated activity on the left side of the image, on the west side of the image. The one big question that I had is why are we seeing more avalanches on that side of the range than on the other side of the range? And it's not necessarily an answerable question, but there's a few ideas to think about. One, the east side of the range, the right side of the image, is in the rain shadow. So even though the Sawtooths are a pretty wet spot, they're a lot wetter on the west side of the range, left side of the image, than on the right side of the image. So you can assume that more snow fell on that left side of the image. And also the terrain is significantly different. That side of the Sawtooth is a lot larger. You see a lot more 2,000 plus foot avalanche paths, 2,000 to 3,000 foot paths, whereas on the east side of the range, you really don't have a lot of big avalanche paths like that. So that's one factor that might influence that. And then thinking back to those early season weak layers, another thing that might influence that is maybe that area didn't have a big avalanche cycle during that January cycle. It's possible that west side of the range, that snowpack was a little deeper, is a little more stable, and so that the big storm in January wasn't enough to trigger those avalanches, but the big storm in March with the shaking may have been. None of those questions are really answerable, but they're all things to think about and things that you can think about thanks to this pretty unique method of looking at avalanches from satellites. So that's kind of a lot of blah blah and a lot of science heavy stuff. I know you guys are interested in maybe seeing some photos of some of this stuff, so I'll give you a little rundown of a few of the features that we saw in these avalanches. Then we'll scroll through a few photos. A lot of these slides had just really odd looks to them, really ragged crowns, a lot of places where you'd have chunks of debris just kind of stalled out on the bed surface. They rumbled down a little bit and then stopped. Widespread rockfall, a number of different places there were major rockfalls. We had a few different typical or popular climbing routes that fell down. We had these deep cracking all the way to the base of the snowpack, even in areas that didn't avalanche. A lot of shattered slopes, slabs on very steep slopes, and then a lot of crowns down in middle elevation, lower elevations, places where you wouldn't, you know, the wind isn't blowing a lot. You're not seeing a lot of effect from the wind. All you're getting is snowfall, which can cause avalanches, but it wasn't really expected with this. And so there are a lot of activity like that seemed a bit surprising. This is a photo. This is just south of Alturas Lake, and you can really gives you a sense for those kind of those ragged crowns that I'm talking about. You can see that if you look closely at the upper bit of that crown, a couple parts of it, you can see where that avalanche stepped down. Slab stepped down to some older weak snow and then stepped back up. Really, yeah, kind of disorganized, ratty crowns. Really not your typical look for avalanche activity. This is looking into the hell roaring drainage. You can see in the top right there a pretty big crown up in the alpine where you'd expect it in this wind-loaded terrain. But then you're also seeing down at the bottom, you kind of look all across there, you can start to pick out all these crowns. I'll highlight a few of them for you. But a lot of crowns on relatively low angle slopes, you know, approaching 30 degrees, areas that are out of the wind, areas where you really wouldn't necessarily expect to see avalanches with, you know, 1.5 feet or 2 feet of snow down there. But there was widespread avalanche activity. We saw a lot of slides on steeper slopes, including this one. This is Horseman Peak. A lot of you are probably familiar with that. You can see a crown running across the middle portion of the face there. And the top of this thing is probably a little steeper than 50 degrees, and where that crown is 45 to 48 degrees-ish. Significantly steeper than where you often see slab avalanche activity. In addition, on the left side, if you look at kind of that notch just left of the summit, you can see all this rock that's been cleared off by a big cornice that came tumbling down and augured through the snowpack. Another relatively unusual feature. We saw lots of stuff that looked like that. It's not uncommon for a cornice to fall, but the amount of them that we saw was pretty uncommon. We also saw these really wild offsetting cracks where you have, you know, looking at this photo, you can see these kind of curved cracks, these curvilinear cracks that run approximately parallel to the slope from the upper left to the lower right of this photo. But then you also have these secondary cracks, these really straight cracks. Highlight them there with those dots. Pull that back, that actually offset those earlier fractures. So looking at this photo, you can tell, you know, the offsetting fracture is going to be older than the original fracture. Somehow this slope first fractured, collapsed and fractured, and then those fractures were offset by these later cracks, which is incredibly bizarre, and I think something that certainly something I've never seen, and I think something that you could probably only produce with some significant ground shaking. This is a photo. We're up by the Banner Summit here, looking down from an airplane. You can see these really widespread cracking, kind of running across the slope here. In a few spots, there have been pockets that pulled out. You can see crowns in a couple of places, but these deep cracks that just run across this entire area. Again, another very strange sort of phenomenon. And lots of rockfall, unsurprisingly. These are the Hanson Lakes there on the right side there, and this is a big chunk of rock that had pretty significant rockfall on both sides of it. One thing that's really neat about this photo is looking at the dust off to the right of the rock, big rock feature there. So that all, as that rock collapsed, it produced this huge dust cloud that flew out and was pushed away in that direction. And as the snow melted, you were able to see that dust a little bit better. yeah, and you can just see how far that must have spread. A pretty impressive thing. And another photo of pretty widespread rockfall. We're in the fishhook drainage here. You can see, yeah, evidence of rockfall in a few different spots. And you can also see, let's see, got there. Sorry about that. You can also see up in the top left is the Barron's Fire. And if you're around this summer, that probably sticks out to you a little bit. So we've talked about the earthquake. We've talked a little bit about the specifics of the earthquake. We talked about how it affected the snowpack. But what is it that happens after the earthquake? And this is something that I hadn't really spent a lot of time thinking about until this happened, and then I've had a hard time not thinking about it for the last number of months. So as I described, earthquakes happen when you have movement, relative movement between two chunks of rock on a big fault, and that the two pieces of rock move and they stop moving, and then there's all these smaller earthquakes that happen as the two chunks of rock kind of settle into a more stable conformation, and these are known as aftershocks. And aftershock sequences are common. They happen with all earthquakes, and they're somewhat predictable. We can predict for any given earthquake that we expect to see an aftershock sequence with a certain number of earthquakes of a given magnitude. We can predict what the maximum magnitude of those might be, but just like with earthquakes, we can't exactly predict when they'll happen. So fast forward a little bit. It's August 7th. I'll try to play a movie for you here. We'll see if it works. I suspect a lot of you have seen this, but on the 7th, there's a magnitude 4.2 aftershock. After epicenter of that aftershock was near Sawtooth Lake, and it toppled the summit block on the Barron's Fire. There's a little bit not friendly for children language in here, but I think I'll be able to edit it out, and this is worth watching. So we'll go through this.
Dude, the rocket! Smoothie's gone off the top! Smoothie's gone! Smoothie came down! Smoothie is gone! Smoothie is gone!
All right, I think I missed the worst of the language. That video is definitely worth a watch. And there's one other video from that same area when that happened. I think maybe the best part of it, it's a little bit subtle, and you heard it in there, but there's the guy who needs to tell you that Smoothie's gone, who's yelling quite loudly, and then there's this one of the other guys who pipes in, "Is that the one that we're going to climb tomorrow?" So I think that's become my favorite portion of that video. Looking at this map, all of these dots represent aftershocks that are part of this aftershock sequence. As of this morning, there's been almost 2,400 aftershocks, including magnitude 3.7 at 6:45 this morning. So that sequence just continues. We're getting towards the tail end of the predictive earthquake or the aftershock sequence, but we're not there yet. Here's a slide courtesy Lee Liberty and Zach Lifton, two of those geologists I mentioned earlier. And there's a lot of info in here, but I would just look at the right side there where it says Amore Decay model. There's a Japanese geologist named Fusakishi Amore who in 1894 identified this relationship where on any given earthquake, you have this certain number of aftershocks, a certain size of aftershock. And it's termed the Amore Decay model. And that thin black line on that you can see that on the image on the right side of the screen there, that's the predicted aftershock sequence. And then the blue line is the observed aftershock sequence from the Stanley earthquake. You can see early on, we were a little bit above it, and then things slowed down a little bit. And we had fewer than predicted, but now we're up to about where that model is predicting. And And then on the bottom, you can see some numbers for the predicted number of magnitude 5, 4, and 3 aftershocks and the actual number. And I would draw your attention to the fact that this model predicts 1 magnitude 5 aftershock, magnitude 5 or greater. And we've had none so far. That doesn't mean that that's definitely going to happen, but it certainly means that it's well within the realm of something that you might expect to happen. I would when we think about these aftershocks, we think about what sort of, at least as avalanche forecasters, what sort of effect they might have for us when we're putting out our forecasts, or as backcountry travelers, what sort of effect does an earthquake have on the snowpack? How big of an earthquake do you need to trigger an avalanche? And this is a really hard question to answer, but there is one really interesting piece of evidence here I'll share with you. 10 years ago, in 2010, in Valle de l'Ession, which is in Switzerland, there's this experimental station set up that is the whole purpose of it is to observe avalanches and try to measure characteristics of them. And it's set up on this mountain with a couple of big starting zones above it, and they have tunnels underneath the mountain with a couple of different types of sensors that can record shaking in the earth and record sound or sonic vibrations from that shaking. And so they either induce artificial avalanches or natural occurring avalanches happen in these starting zones, and then they watch them as they come down. And on December 10th or December 12th in 2010, there was a small earthquake, a magnitude 3.1. So again, there was a 3.7 in Stanley this morning that triggered a persistent slab avalanche. There were some facets on top of a melt freeze crust. And so they were able to image this event where the singular avalanche, the small avalanche, actually triggered a persistent slab avalanche, or the small earthquake, excuse me, actually triggered an avalanche. So we don't have a lot of information down at this lower end of the spectrum. We know that big earthquakes can cause avalanches, but it's really fascinating to me that such a small earthquake can have an effect on an unstable snowpack like that. And I think this matters for us because, you know, if persistent slab sounds familiar to you, melt freeze crust with facets sound familiar to you, it sounds pretty familiar to me too. We deal with those quite frequently. And you know, as we enter this winter, we're still in this ongoing aftershock sequence. It's not uncommon to see, you know, obviously there's a magnitude in the same area of the Stanley earthquake in 1944 and 1945. There were 2 magnitude 6 earthquakes, a magnitude 6 and a magnitude 6.1. The magnitude 6 followed the 6.1. Some workers think that itself was even an aftershock. So this is it's a highly active area. It's an area that can produce large aftershocks, and this is where we're recreating when we go into the mountains. I think it's something that I think about as far as the snowpack. It's something that I think about as far as getting into a steep couloir where there might be loose rocks on the side. These things, they're unpredictable and specific. We can't say at any point when a given aftershock might happen. But in bulk, they're moderately predictable, and we can say with some certainty that there will be more aftershocks, and that those aftershocks will be, given our example from Switzerland, will probably be large enough to trigger earthquakes, or to trigger avalanches, excuse me. So it's not easy to deal with. It's hard to know exactly what to make of that, but it's something that I think that bears keeping in mind and bears thinking about as we move forward into the future this year. And with that, I would open it up to questions from any of you guys. I'd be interested to see what you're curious about, what you want to know more about, what you want to correct me on, and yeah, let's see what you got.
Awesome. Thanks so much, Ben. That was seriously fascinating. And for everyone watching, as Ben had described at the beginning of his talk, if you have any questions, you can type them into the Q&A button at the bottom of your screen, or there's a raise hand feature, and then I can click on you and unmute you, and you can ask it. So as you think of your questions and type them up for us, Scott is going to play that quick Friends video for us. So in the meantime, Ben, if you don't mind unsharing your screen, then we will reshare you up after the video when we get all the questions poured in.
The Friends of the Sawtooth Avalanche Center's mission is to support the Sawtooth Avalanche Center and promote life-saving avalanche safety information, education, and outreach throughout South Central Idaho. So in this case, your donations would help support our forecasters who produce the fact-filled daily avalanche forecasts we rely upon all winter for safe travel in the backcountry. And your donations would help pay for the ever-evolving and information-packed Sawtooth Avalanche Center website. And your contributions would help to provide essential educational outreach to our community. So really, every donation, no matter the amount, would really be so important in helping us meet our mission. And every donation, no matter the amount, could actually help save a life.
So thank you for sharing that, Scott. So it looks like we have a lot of questions pouring in. And to follow up on that video, yeah, we just want to thank everybody again, everyone who's contributed to the Avalanche Center and the Friends group before. It really does make a difference no matter the amount. And if you feel like donating, there's a link on the website, sawtoothavalanche.com, or you can look us up on Venmo. So thank you for everything that people have donated to in the past. So back to the earthquakes and avalanches. Ben, are you ready for some questions?
I am ready. I don't know if it's easier. I see a bunch in the Q&A. I could probably just read through these maybe.
Sure, yeah, if you can see them on your end.
Or if you
answer,
yeah,
go
whatever
for it.
works. Let's see, we've got Mitchell Krillman's asking, has there been any similar analysis of avalanche cycles following earthquakes? There's a document that records all known avalanche or earthquake-induced avalanches. There's only about 20 of those in there. This event is really, really unique in that it happened in an area where there's people to see it. There's people who know snowpack characteristics leading up to it, and it happened during high danger, and it was a major earthquake. So it's a pretty unique overlap of events, and I'm not sure of any other. I know of no other event that contains the overlap of all those different things, and I don't know of a similar analysis of an avalanche cycle following an event.
It looks like we've got a hand raised. If you want to do
Oh yeah, that sounds good.
Cool. We've got Carl Fosfet here. And let's see. I think we can. All right, Carl, you can unmute yourself and ask your question.
Nice. Hey, Ben, can you hear me?
I can hear you, Carl.
Right on. Hey, I just wanted to ask you guys, following the earthquake, it seemed like there was kind of a mentality amongst a lot of people I recreate with that, like, all right, we have a free pass to go in the backcountry, and like there's no way that you can trigger an avalanche after this earthquake came through. Like any avalanche that is triggerable has already been triggered. I try to avoid having that mindset, but it does seem like at some point there's kind of like, you should definitely not just, you don't have a blank check. You can't go do whatever you want. But, do you think that there was kind of a point in time there, it's like, all right, it is kind of a safe time to go out right now following the earthquake?
Yeah, great question, Carl. Tough question.
Yeah.
I think, it's hard to say. I mean, conceptually, if you induce a bunch of motion in the snowpack, if you, whether it's throwing bombs at something or ski cutting something or whatever it is, that you didn't trigger an avalanche with that that impetus, that force that you put on it. But it's hard to, you can't really say that just because that didn't trigger an avalanche isn't possible to be triggered. I think that it's probably undoubtedly true that the likelihood has gone down significantly, but I think my personal travel strategy didn't really change much, just because there's so much uncertainty around it. I mean, you can't use the pattern recognition of like, oh, I've seen this before. There was an earthquake before, and then there weren't avalanches, so it's good. So it's hard to have any real confidence in that, especially when you're betting with your life, to put it a bit crassly.
Yeah, amen. Well said. I appreciate the feedback. And at what level earthquake do you think we could say that there's no chance a human could trigger it following? Or like, what do we need at 8?
That's a good question. Yeah. Let's say 8, but 6.5 is the biggest. So the size of a earthquake that any given fault can produce is proportional to the length of the fault.
Mm-hmm.
So the Stanley fault, or the Sawtooth fault, excuse me, just isn't that long, and this is about the biggest earthquake that it could generate. So I would say no earthquake on the Sawtooth fault would be big enough to say that it's good to go.
Cheers. Thanks, man.
Yeah, thank you, Carl.
Thanks, Carl. All right, Ben, we've got another question, one from Sam Box. He says,
Okay.
Very interesting talk. Thanks for putting that together. More of an observation than a question, but didn't the series of, oh boy, I'm going to botch this word, covelinear, if that's correct, did the series of covelinear cracks with perpendicular straight cracks look remarkably similar to maps of fault zones, kind of like that Sawtooth map zone?
Yeah, definitely. I mean, you're looking at offsets. You're looking at one set of fractures that are offset by another fracture, or one set of features that are offset by another feature. If you go to Google and you type earthquake or fault line, you'll see a lot of images that look not terribly dissimilar from that, where you have an existing structure, whether it's sedimentary bedding or whatever it is, and then it gets offset by that faulting, and you can see that clear offset. I don't know if that answers your question, Sam.
Yeah, Sam, feel free to type a follow-up question if you'd like. In the meantime, Zach Bell is asking, how does this year compare to others regarding tectonic activity? Should we be concerned with the frequency of aftershocks this year?
Yeah, good question, Zach. So we're towards the tail end, or the predicted tail end of this aftershock sequence, but there are more aftershocks that will happen without a doubt. I mean, there was one 12 hours ago that was big enough to rattle the dishes in Chris Lundy, one of our forecasters' house. So we know that it's ongoing. As far as just kind of general tectonic activity goes, earthquakes they're predictable in bulk over long time scales, but individual earthquakes aren't predictable. So we can look at a given fault and see that it's had 5 earthquakes in 100 years and say that on average there's an earthquake every 20 years. But that doesn't mean that we might not get one, 2 years back to back and then not see another one for 50 years. So it's kind of, it's hard to say specifically. But it's, we're in a seismically active area where earthquakes happen. There's been, 5 major earthquakes in this area in the last 80 years, and there will be more without any doubt. So.
All right, there's a good one in here to follow up with that from Will. So are Sawtooth Avalanche Center danger ratings going to be more conservative this winter due to potential earthquake hazard?
Yeah, that's a great question, Will. I think we will continue to assess snowpack stability and issue avalanche danger ratings as we normally do any given year. The the seismic problems, the tectonic problems, earthquakes just aren't predictable, and they don't really fit into the framework of what we do. But I don't think that means that maybe a person might not want to be a bit more conservative. I mean, I know personally, I was quite conservative last year just because of uncertainty, not because of not because I had a problem to point to, not because I expected something to happen, but just because I didn't really know. And obviously, given this is a completely unique event, not something that anybody anywhere has experienced in recorded memory. I think that I would advise you to think about it that way as well. If that answers your question well.
Great. If anyone else has questions, feel free to keep typing them in the chat there. Will says thanks. Cool. So actually our very first question that came in was from Madonna, and she's asking where was that brown rock? That's a tongue twister. Where was that brown rock blowout? And I'm assuming she's referring to that photo that you took, or maybe Tanner took that photo in Stanley that was clearly rockfall.
That was by Hanson Lakes, kind of in the northern section of the Sawtooth there.
All right, well, there's one more question in here that says, do you expect this to be an earthquake aftershock winter? Which it sounds like, Ben, you've talked about those kind of answers already, but if you have other things to say, and I would tag on to that question with, what advice do you give to people when we're looking at the forecast, planning our day, and having the idea that earthquakes are possible and the mindset of conservatism and increasing our margins? Like, the idea is great, but then what do we actually do about it?
Right. There's the $1 million question. I was waiting for the hard one to roll in. It's hard to answer. I think the best thing you can do is be aware of it. Obviously, you can't know when an aftershock's going to happen. You can't know when an earthquake's going to happen. And it's not like the earthquake hazard didn't exist in this area before this earthquake. I mean, nothing about the geologic setting of the Sawtooth or of this entire area has changed because of this earthquake. It's kind of in the front of your mind a little bit, and it's just one more of the hazards that you may or may not encounter in the backcountry. It's kind of your classic low probability, maybe really low probability, and potentially no consequence or potentially really high consequence problem. And I think if you're keeping that in mind when you're traveling in the backcountry, like if you find yourself somewhere and if you're uncomfortable being there, you're questioning being there in the first place, and then if you're at the point where you're thinking about whether or not an avalanche or an earthquake aftershock means you should or shouldn't be there, I think maybe you're asking the wrong questions or thinking about it or maybe it's worth thinking about it in a different way. I don't know if that answers that at all.
Well, thanks, Ben. So we've got a few more rolling in. We'll keep firing away.
Do it.
Ryan S. is changing the subject slightly with his question. Did the cohesiveness of a snowpack contribute to not feeling a seismic event happen at a remote location while skiing, or was it just not having a perspective during the storm to feel the shaking? I would add on,
great.
were you driving when you felt when the earthquake happened?
Yeah, that's a good question, Ryan. I was driving. I was no longer out in the backcountry when that happened. But there is a dampening of the earth movement that happens if you're on the snowpack or if you're on anything. A dampening or an amplification, for instance, in areas that have tall buildings, oftentimes the people at the top of the building can feel earthquakes or aftershocks, whereas people on the ground might not feel them at all. The relationship between the snowpack and the ground, and how the snowpack shakes and vibrates during ground motion caused by an earthquake is not studied at all. Not something that anybody knows, but I think that I wouldn't be surprised if you were standing on the snow, that maybe it would have been a bit harder to feel that than if you were standing on solid rock, if you were standing on the ground, just because the snow will, as the earth is kind of moving back and forth, the snow is kind of moving with it, but it's dampening those vibrations and not moving as intensely, if that makes sense.
Great. Yeah, that reminds me of the many articles that came out interviewing Chris and Sarah Lundy when they were at the Williams Peak during the earthquake on March 31st. And so they might have some insight on what that felt like being in the mountains, and the year is still a structure, but on the snowpack. Those, you could Google those and get some of their insight. Okay, so anonymous attendee, did today's aftershock cause any slides? You mentioned that the aftershock window is almost done. When is it predicted to be completed? Thanks, Ben. Cheers.
As far as if today's aftershock caused any slides, I don't think, none observed that I'm aware of yet, but kind of like that image I was showing you with the east side of the Sawtooth and the west side of the Sawtooth, a huge portion of the terrain we just don't see, and we just never see. It's just too far away to really get there with any reliability. It's a good question. No observed avalanches. Could it have caused an avalanche? I guess hypothetically it could have. If it did, it would have been almost certainly on that weak snow near the ground. But we're into the land of speculation at this point.
All right, so Carl has a follow-up question.
Okay.
Where was the largest slide associated with the earthquake observed?
Yeah, that's a good question, Carl. It was interesting. There weren't that many like truly large avalanches, because, or my take on that was because a lot of those deeper instabilities had been kind of dealt with, or were really unstable. They got flushed, and then they got buried in other spots, and weren't nearly as unstable there. The biggest, surprisingly, there's actually some big slides in the headwaters, kind of on the backside of the Smoky Crest there. There were some, D2.5 avalanches, some deeper slides, deeper pockets that broke out in the Banner Summit area where you're rumbling down to that weak snow near the ground. And then, I think some of those, probably the biggest avalanches were, if you think back to that figure I showed with the east side and the west side of the range, some of the biggest ones were probably on the west side of the range, below those big paths where, even a small or a relatively small avalanche can gather up debris as it's flowing downhill and, collect a huge amount of snow as it travels downhill. But we really didn't observe very many or any really big, impressive, deep avalanches. There's a lot of relatively small, and relatively, these all, or vast majority of them, easily could have buried you, but relatively small avalanches.
So Frank Waters is asking, well, first he says fascinating information. And are earthquakes common in other Western mountainous regions?
Yeah, good question, Frank. I showed, if you somehow send Amy or us your email, I can send you a figure. I've given a different version of this presentation to some professional groups, and I actually overlaid what's known as the National Seismic Hazard Map, which essentially is just an empirically created map. It's created from a observed evidence of active earthquake activity in the US, and it shows areas where damaging shaking is predicted to occur at least once in a 100-year period. And a lot of the avalanche centers in the Western US lie in that. Colorado is kind of down in the cold crust, not a ton's going on down there. You might be all right. Southern Utah, same sort of thing. But you get further north, get into northern Utah, into Idaho, southwest Montana, even northwest Montana. A lot of the Northwest is pretty seismically active. The mountains that most of us play in are products of of tectonics. They're products of moving around, whether it's two pieces colliding and thrusting a piece up in the air, or one dropping down relative to another, like on the Sawtooth fault, and then the one that stays up in the air is the Sawtooth range, and that's where the mountains are. In general, mountainous areas are areas of seismic activity.
Okay, this question is ramping it up a bit. So it's anonymous. Hi, Ben. It seems to be logical that an earthquake would cause avalanching even in a primarily stable snowpack due to the rippling of the Earth's surface. I'm curious as to what, moving forward, the takeaway of this might be without seismic detection or remote sensing means, I'm not a geologist, means to help with a predictive methodology for use in the future. Subsequent question, more avalanching on peaks versus troughs of seismic waves throughout the zone.
Oh man, let's see.
Yeah.
I'm digesting
You might need to
this.
read that one to get a refresh
on. Yeah, so avalanching occurs when you have a relatively weak layer of snow that collapses, and then that collapse propagates a fracture out across a slope. That weak layer of snow is pretty important there, and snow can actually be really, really strong. So in a stable snowpack, the snow is not terribly brittle. It's actually pretty ductile, almost rubbery. And kind of imagine when you're digging into a deep, stable snowpack, and it's all just like pretty dense snow. Like maybe if you're out now, ignoring the weak snow near the ground, and that snow can actually deform considerably without breaking. And that's kind of the principle behind earthquake engineering with buildings, is that you make them so that they're not brittle. They don't want to break. They just kind of want to like sway back and forth with the earthquake. So a strong, stable snowpack, really there's no reason to think that there would be avalanching aside from like a huge magnitude event where it's just the mountains are falling down anyways, so the snow's obviously falling down on top of them. I guess I'm not quite following the subsequent question, the follow-up question that they've got there. So if you want to maybe like try to reword that or something, I'd be happy to try to address it.
Yeah, for whoever wrote this question, if you'd like to reword it, or feel free to hit the raise hand button down at the bottom, and it might be easier to ask the question with the unmute feature. And for anyone else, feel free to ask your final questions. We've got a few more minutes on here with Ben, but we've got him here to answer any questions. Any other final bits of advice or thoughts going into this season, Ben, as we're waiting for a few more questions, or not?
Well, I mean, it's interesting to think about, I talked a little bit about, we have weak snow on the ground. It's pretty isolated, but there is weak snow there. If we shake it, I guess we don't really know what's going to happen. Like I said earlier, it's actually really hard to study these sorts of things, because unless you have these major, like a big earthquake, either a really big earthquake or really unstable snowpack, it's hard to say with any certainty that this avalanche was caused by the earthquake. And that's even true for a lot of these, these avalanches. Like I presented in that talk, I was finding large natural avalanches before the snow got shaken. And as we traveled around and looked at these things, it was clear that they didn't all happen all at the same time. But if we look to Chris's experience, if we look to reports from folks in Stanley of being able to hear avalanches coming off the mountains in the aftermath of the earthquake, we know that that earthquakes cause avalanches. But as far as being able to specifically ascribe a certain avalanche event to an earthquake, that becomes really, really, really difficult without, these really specific conditions, like having, like in Switzerland, that example I described, where you have, underground tunnels that have these instruments that can, detect the avalanches they happen and things like that.
So Carl has another question. Did you guys or anyone fly over the range after the earthquake?
Yeah, good question, Carl. I, thanks to a very generous donor who wants to remain anonymous, I was able to do an overflight from Haley, basically went from Haley along the crest of the Pioneers, up the White Clouds, a couple laps around Banner, back down the crest of the Sawtooth and the Smokies. But I think that was the 9th of April. So that was almost 10 days after it. So a lot of and in those 10 days, there's a mix of a bit of snow here and there, sunny conditions here and there. We were seeing some wet loose problems and starting to see some pretty significant wet slabs also. So at that point, you were far enough out that it was even harder to attribute specific avalanches, even to that time frame, that avalanche cycle, let alone to the earthquake in specific.
So, and a quick follow-up to that is, do you know if anyone was able to document the western half of the range from the air via plane or heli?
Yeah, so when we flew, we came down basically along a little east of the range crest. And that image I showed with the remotely sensed, the satellite detections of avalanches on the west side of the range, those came, I didn't have that image or the access to that information until later. I suspect I would have pushed a little harder to spend a little more time over there, but we were kind of, they're big mountains and you can only go a couple places at a time. So we didn't get a chance to really look at a lot of stuff. No.
Okay, and then here's our last grand finale question that everybody wants to know. Do you expect a big snow year?
The answer is always yes. You gotta be optimistic, It's gonna be huge out there.
All right, you heard it here, folks. With that, we just want to say thank you. On behalf of the friends, we want to say thank you to Ben for taking the time to put this together and sharing your great amount of knowledge with us. And also thank you to all of the other forecasters who've been helping behind the scenes to make the Digging Deeper series possible. We've got Scott Savage, Ethan Davis, Chris Lundy, and we want to give a big thank you from everybody at the Sawtooth Avalanche Center to the Sawtooth Brewery, Paul and everybody there. We really appreciate all of your continued support throughout the years. And if all of you listening are out in the mountains or driving on the road and take some great photos or see different observations within the snow or the mountains, feel free to tag us on social media, share what you see at Sawtooth Avi, or go to our website, sawtoothavalanche.com, where you can submit an official observation or shoot the forecasters an email, and it really helps with putting the big picture together. So again, thank you everybody for listening, and we hope you tune in for the next Digging Deeper series on December 9th. That's with Chris Lundy, and he will be talking about the websites and technology updates that will help you better understand the forecast and how you can utilize the Sawtooth Avalanche Center products. So thank you, everybody, and have a happy Thanksgiving.